Let's get started on lesson 1.7 with our first topic, factoring the sums and differences of perfect cubes. We already know how to factor a perfect square minus a perfect square, as long as we have perfect squares. Well, we got x squared, subtract 4 squared, so we can go with it. You could factor this as x plus 4, square root of x squared is 16. And then in the second factor, you'd have to have the opposite sign, x minus 4. If you prefer, you could reverse it. You also learned to solve the equation x squared minus 16 equals 0 to find the roots by factoring. Meant that x equals negative 4 or x equals positive 4. They're both roots. They will both satisfy that equation. How about x squared plus 16? Could we do that? Well, it turns out that doesn't work too well with the equation. If we try x squared plus 16 equals 0, we get x squared equals negative 16. Whoa. And that's not going to happen. There's no way we're going to take the square root of a negative number. So we forget the sum of two perfect squares. You can take the cube root of a negative number, though. So we are going to be able to do x cubed plus 125. Couldn't do if this was perfect squares, but you can do it with perfect cubes. Well, are these perfect cubes? Well, yeah, x cubed is a perfect cube. You cube an x. 125 is the perfect cube on 5, because 5 times 5 times 5 makes 125. So we are going to be able to factor this. First factor's really easy. You take the cube root of x cubed plus the cube root of positive 125. Then the second factor is going to be a little bit longer. It's going to be a trinomial. We're going to have to think a little bit. We're going to find out what goes first, what goes last, and then the magic's going to come when we figure out the middle. So first, what do we multiply times x to get x to the third power? Well, we'd have to multiply x times x squared. So that's what goes in the front. And then at the end, what do we take times positive 5 to get positive 125? Well, if you know that 5 quarters are worth $1.25, you know that this would be 5 times 25. So this is a positive 125. Now for the middle term, we go back to the first factor. We multiply these two together and change the sign. So 5 times x is 5x, and then we change the sign, and this will be a negative 5x in here. Don't believe it? We'll check it out. We'll actually do the multiplication and find out if it comes back out to what we started with. So x times x squared is going to be x to the third. X times negative 5x, negative 5x squared. X times 25, be a positive 25x. And then coming the other way, multiplying by the 5 times x squared, 5 times negative 5x, 5 times a positive 25, and then the negative 5x squares cancel with the positive 5x squares. the 25 and negative 25x's cancel out, and we're left with x cubed plus 125, and that is what we started with. So let's try another one. This time we have the difference. This is going to look a little silly, but do we have a perfect cube minus a perfect cube? Yep. We've got 1 cubed minus a cubed. So we can do this. Our first factor's going to be the cube root of 1 minus the cube root of a cubed, which is pretty obvious here. So then what do you multiply times 1 to get 1? Well, we got that. At the other end, what do you multiply times negative a to get negative a to the third? Well, if we're starting with a negative a and we ended up with negative a to the third, what we multiply would be positive a squared. Negative a times positive a squared is going to make negative a cubed. And then to get the middle term, we're going to take the negative a times 1 and change the sign. So negative a times 1 is negative a. Change the sign, that would be positive a. And that would be the factorization. Once again, we can check it out. 1 times 1, 1 times positive a, 1 times positive a squared, negative a times 1, negative a times positive a, negative a times positive a squared. The a's cancel out, the a squareds cancel out. It's 1 minus a cubed. That's what we started with. One more. So do we have a cube and a cube? We do. I hope you know what we would cube in order to get 8. Maybe a 2? 2 times 2 times another 2? So this could be rewritten as 2x cubed. That would give us the 8 times the x cubed. And the other one, 27. So think of what you take times itself and then again times itself. And I believe you know that that's going to be 3 cubed. So our first factor's going to be the cube root of 8x to the third, which is 2x. Our second factor is going to be the cube root of 27, which is 3. So now, to get each of these 3 terms, we start at the front end. What do we multiply times 2x to make it come out 8x to the third? So 2x times something has to come out 8x to the third. Well, that would be 4x to the second. And then at the other end, what do we multiply times positive 3 to get positive 27? Well, that would be a positive 9. And then the middle, we're going to go back to the first factor, multiply these two together, change the sign. So 3 times 2x would be 6x, change the sign, and we'll complete this with negative 6x. And that would be the factorization for the sum of those 2 cubes. And now it's time for you to go and try some practice problems on your own.